Hi everyone. Today we're going to study logarithmic functions. Let us define logarithmic function. For b greater than 1, the b is the base, and b is not equal to 0, the inverse of f of x equals b raised to x. This function is an exponential function denoted by f inverse of x equals log of x base b is the logarithmic function with base b. The general form of logarithmic function is f of x equals log of x to base b. So in here, the inverse of the exponential function is the logarithmic function and vice versa. We read this notation as log of x to base b. Please note that x equals b raised to y is equivalent to y equals log of x to base b. This is the exponential form, and this is the logarithmic form. As an example, if we have 3 squared equals 9, this is equivalent to log of 9 to base 3 equals 2. Take note, the number 3 here is the base of the exponent, and in the logarithm, the number 3 is also the base. The number 2 is the exponent, and that is the logarithm value of the logarithmic form. And this number 9 is the same number for the logarithm. Here is a quick look of the graphs of logarithmic function. This is the graph of y equals log of x to base b, where b is between 0 and 1. While this is the graph of y equals log of x to base b, when b is greater than 1. Let us proceed with properties of logarithmic functions. If b, capital M, capital N are positive real numbers and b is not equal to 0, and p and x are real numbers, then we have here the first 4 properties of logarithmic functions. Number 1, log of 1 to base b equals 0. Property number 2, log of b to base b equals 1. Number 3, log of this b raised to x to base b equals x. And this x is simply that exponent of the b. Property number 4, when we have a number b raised to log of x to the base b, this is equal to x, and this x is the number of the log. There is a condition that x is greater than 0. It means x must be positive. Let's have the 5th, 6th, 7th, and 8th properties of the logarithmic functions. Let's have number 5. The log of m to base b equals the log of n to base b if and only if capital M is equal to n. This property is used normally when we are solving equations. Property number 6. This is the log of a product mn. If we're going to take the log of the product mn to base b, this is equal to the log of m to base b plus the log of n to base b. Property number 7. This is the log of a quotient. When we have m over n, and we will take the log of that to base b, this is equal to the log of capital M to base b minus the log of n to base b. Property number 8. The log of this m raised to an exponent p to base b, this is equal to the p, which is the exponent, is now put down as a factor. So this is p times the log of m to base b. Take note of this property 6, 7, 8. Because the logarithm lightens up the respective operations. Look at the product. This is equal to the sum of each factor. For number 7, the division becomes subtraction. And for number 8, the exponent or the power becomes product in here. There are types of logarithmic functions and relationships. The first is the general logarithm, where we see y equals log of x to base b. The condition is b must be greater than 0, or we say b is positive, and b is not equal to 1. Also, x must be greater than 1. The next type is common logarithm, and this is equal to y equals log of x to base 10. We say that this is common logarithm when we have a base of 10. And if we have a base of 10, we can simplify the log notation into log x. So in here, the base is not written. So every time we see a log without any base, that is understood to be base 10. And we call this common logarithm. The next type is natural logarithm, and this is y equals log of x to base e. And we can simplify the notation by writing ln of x. This ln of x means it is a logarithm with base e. There is a relationship about log of x to base b. We can simplify this by taking the quotient of log of x to base 10 over log of b to base 10, or we can write ln of x over ln of b. Take note, the log of the x will be in the numerator, and the base, which is the b, will come as the log of b in the denominator. Let's go now to examples. This is example 1. Change each logarithmic form to an equivalent exponential form. We have here our conversion formula. So the letter A is log of 5 to base 25 equals 1/2, and letter B, log of 1000 to base 10 equals 3. So let's start with letter A. This is the equivalent exponential form. Take note, this is log of 5, so we will write here the number 5 equals, the base is 25, so we will use this base as the base of the exponent. And this 1/2 here is exactly the exponent. So we have 5 equals 25 raised to 1/2. So this is the answer for letter A. For letter B, the equivalent exponential form is 1000 equals 10 raised to 3. From the given problem, log of 1000, we're going to write this 1000 again here, and this is equal to the base 10 of the log is the same base for the exponent, and this number 3 is the exponent in here. So 1000 equals 10 raised to 3. This is our final answer. Let us have the reverse process. Change each exponential form to an equivalent logarithmic form. Again, let us write our conversion formula. And we have two problems here, A and B. This is 36 equals 6 squared. And letter B, 7 equals square root of 49. Let's begin with letter A. And this is equivalent to 2 equals log of 36 to base 6. Now, this number 2 is the exponent of our exponential form. And we write equals. We put the log of the number 36, we copy here. And the base 6 of the exponent is the same base of the logarithm. So this is our answer for letter A. Now for letter B, 7 equals the square root of 49. Let us convert the square root of 49 into rational exponent. So we have 7 equals 49 raised to 1/2. And from here, we will now write the equivalent logarithmic form. This is the equivalent logarithmic form. The 1/2 or the exponent in here will be our answer here, 1/2, then equals. We will write the log of the number 7, we will write here, and this base 49 of the exponent is the same base for the logarithm. So our final answer is 1/2 equals log of 7 to base 49. This is our final answer. Let's have example 3. Find x, b, and y as indicated. So we have here 3 problems, A, B, C. Letter A is log of 16 to base b equals 2. Letter B, log of 64 to base 8 equals y. Letter C, log of x to base 2 equals 3. First, let us write our conversion formula here. Our main goal now is to convert each of these problems into equivalent exponential form and solve using exponential property. Let's begin with letter A. The equivalent exponential form of letter A is b squared equals 16. The b is the base, so I write the base here, and this number 2 is the exponent, so we have b squared. And this is equal to this number 16. Now, I know that this 16 is the square of 4. So I can show that b squared equals 4 squared. And then I'm going to use a property of exponential function. I remember there is property number 3 that says a raised to x equals b raised to x if and only if a equals b. I can see here that the exponents are the same. So it means I can simply copy the b down here equals 4. So I have here b equals 4, and this is my answer for letter B. It means the value of b equals 4. I will just copy this answer opposite letter A. I will go now to letter B. I will convert this into equivalent exponential form. And this is the exponential form. 8 raised to y equals 64. Again, we see the base here, the log with base 8. I copy that same base in here. And this y is the exponent that I can use here. So 8 raised to y. And this is equal to, this number 64 is now here. And I know this 64 is equal to 8 squared. So I have now 8 raised to y equals 8 squared. In this portion, I can see that I have same base for the left and the right sides of the equation respectively. So I remember property number 2 of exponential function, and that is a raised to x equals a raised to y if and only if x equals y. I can see that I have same base, so it means I can copy the exponents of the left side, which is y, and this is equal to the exponent of the right side, which is 2. So I have now this equation, y equals 2. And this is the value of y that I want to derive from problem B. So I'll just copy this answer opposite letter B. The y equals 2. I will go now to problem C. The log of x to base 2 equals 3, and I will find the x. I will now write the equivalent exponential form of letter C, and that is 2 cubed equals x. Again, the log with base 2, I will copy that number 2 here as the base also of the exponent. The number 3 is the exponent itself. So that is 2 raised to 3. And this is equal to this number x. And I will copy it here. I will just simplify the 2 cubed, and this will give me 8. So 8 equals x. And this equation gives me the value that I want, that x equals 8. This is my answer. I will just copy this opposite letter C. So we are now complete with our answers for A, B, and C.